Hello friends, welcome to Learner's Planet. Friends, this is our basic concept session for lines, triangles, quadrilaterals and other polygons. In this session, we'll be discussing the very basics like terminologies, theorems related to all these topics I can say. So let's begin the session. Now here are some very basic definitions. Some terminologies are given over here, though you know all of them, but we just go for a quick recap. So the first is point. Don't have to explain much because you know what's a point. A point is that which has no part. A point is represented by a fine dot made by a sharp pencil on a sheet of paper. What's the plane? The surface of a smooth wall or surface of a sheet of paper or the surface of a smooth blackboard is closing examples of plane. Line, you know, it's a breadthless length, right? That is edge of a ruler, the edge of the top of a table, the meeting place of two walls of a room is also examples of a geometrical straight line. You can see the sign, the arrow on both the sides, right? That means this is not a complete line. Actually it can move in both the directions, right? In this side and in this side, right? So if we have a lines, what is the difference between a line and a line segment? See, line segment is this, right? When you don't see arrows on any of the side, then it's a line segment. That means it cannot move on any other side, right? And if you see a diagram like this, this is known as a ray. It cannot move from this side, but it can move in this side. Okay, so the difference between line and line segment: line can move in both the direction, line segment cannot move at all, right? But in our day-to-day language, when we solve the problems from geometry, we generally call line segment as line only, right? Suppose I have this triangle, okay, though I know there are three line segments over here, but we just call them lines. Okay, so do not get confused. When I speak line, I mean sometimes we speak about this, sometimes we speak about this. Okay, three or more points are said to be collinear if there is a line that contains all of them, right? That means suppose here we see the 3 points A, B, C. So if A, B, C, all of them are on a single line, then we call them as collinear points. Next is concurrent lines. 3 or more lines are said to be concurrent if all of them pass through a common point. Okay, two distinct lines cannot have more than 1 point in common. I just draw some diagrams over here. Suppose I have this line, then this line, this line. See, all the three lines, they are passing through a common point, so we call them as concurrent lines. Now the second point is, see this line and this line, you just see that they have just 1 point in common, that is this, right? So two lines, when they are intersecting, in fact they cannot have more than 1 point in common. Okay, so that's pretty important. Concurrent lines, if the lines are passing through one common point, they are known to be concurrent lines. Similarly, we can call them as intersecting lines also. Suppose I have this line and this line, so both of them are intersecting line. Intersecting line, that means they are intersecting each other, right? So these two are intersecting lines. So either there are two situations, either the lines are intersecting or parallel. If the lines are intersecting anywhere in the plane, they will definitely intersect, right? If the lines are parallel, they will never intersect with each other. I just draw, suppose I have this line and this line. Okay, now these two are parallel lines and these two are intersecting lines. Now what would happen? These two lines will never intersect in the plane, and in otherwise we can say the angle between these two lines is 0. These two lines is 0. And these two lines, suppose I can take one more example. So over here, one more example. Suppose I have this line and I have this line. Okay, now you just observe the difference between this set and this set. These two lines are parallel to each other, they are never going to meet, but these two lines in first glance you find them to be parallel, but these are not parallel. If you keep on extending the lines, they will meet somewhere, right? So if you keep on extending, it's something like this. I'm not able to draw the line very neatly, and if you keep on extending this, they will meet somewhere. Now you can see it very clearly, right? So at this position they seem to be parallel, but they are meeting in the same plane. So these are intersecting line. That means there is some angle between the two lines. So when there is some angle between the two lines, then the lines are intersecting. When there is no angle, that means a zero angle between the lines, then the lines are known to be parallel, right? So in geometry we have different conditions for intersecting line, different concepts, different conditions for intersecting lines and parallel lines, that we'll study in detail later on. Now just now we talked about angle between the lines, right? Here we discuss more about it. The sum of all the angles round a point is equal to 360 degree, and if the two lines intersect, then the vertically opposite angles are equal. See, when you see the two lines over here, this is one line, this is the other line, they are intersecting at any point. Maybe this point is O, right? Then the angle, vertically opposite angles will be equal, right? When you see the shape of V, right, here you can see this shape of a broad V, here this is a broad V, so this angle will be equal to this angle, and similarly this angle will be equal to this angle. So when you see this shape, right, just take this, the vertically opposite angles will be equal. So this angle will be equal to this angle, and this angle will be equal to this angle. Okay, so vertically opposite angles are equal. This is very important point, you should note it down. Okay, we'll be using this point, this concept many times while we'll be solving the problems when we have to find out the angles, okay, in the given questions. Now that's very important concept we are going to discuss now. If a transversal intersects two parallel lines, then each pair of corresponding angles are equal. See, I have drawn a set of lines over here. This line is parallel to this line, and the green is a transversal that is intersecting both the parallel lines. Now various angles are formed over here that you can see, A, B, C, D, E, F, G, H. Now there exists a relationship among all these angles. Now what these relationships are, let us discuss in detail. So for that I just draw two more parallel lines over here and just try to make the same set. This is the line, then I have one more line. These two are parallel lines, and this is the transversal. Okay, now just name them A, B, C, D, E, F, G, H. Now we'll talk about various angles. The first is vertically opposite angle. We just talked what are vertically opposite angles. So here we can see various pairs of vertically opposite angles, the angles between the two lines, right? So here B and D, vertically opposite angles. Then A and C. Then F and H. Then G and E. So these are the pairs of vertically opposite angles. So angle B will be equal to angle D, angle A will be equal to angle C, angle F will be equal to angle H, angle G will be equal to angle E, right? So you must be knowing what are vertically opposite angles. Next thing which we are going to discuss is corresponding angles. Now corresponding angles, that means both the angles should be on the same side of parallel lines. Either both of them should be above it or both of them should be below it. Below them, below them or above them, right? So here we can say this line, suppose this is line L and this is line M. Over here, this angle, angle A and angle E Both of them are on the right hand side of this transversal, and both of them are on the above side of the parallel lines, right? So angle A will be equal to angle E, and the reason is they are corresponding angles, that means same side, right? So corresponding angles are equal. Similarly, D is equal to H. Angle D is equal to angle H. For the same reason, corresponding angles are equal. Both of them are below these parallel lines. Similarly, on this side, angle B is equal to angle F. Corresponding angles are equal. Both of them are above this parallel lines. Then angle C is equal to angle G. So 4 pairs of vertically opposite angle, 4 pairs of corresponding angles, right? So you must be knowing all of them, because we don't know, we cannot say at what time which property, which combination will be used. You must be knowing all the combinations. Next is alternate angles. Now for alternate angles, you can see a shape of Z, right? When you see a shape of Z, this angle will be equal to this angle. That means one angle is on the left hand side of the transversal and other is on the right hand side of the transversal, right? So over here, just see, we can see this shape of Z. So this angle, just change the color. This angle will be equal to this angle, right? So angle C is equal to angle E. Similarly, we have angle D is equal to angle F. Okay. These are known to be alternate interior angles, right? Because all of them are on the inside of this parallel lines, right? Similarly, we have external, that is I can say exterior alternate angles, right? So angle B will be equal to angle H. Now that's very simple. See, B is equal to D, D is equal to H, D is equal to H because corresponding angles are equal, B equal to D because vertically opposite angles are equal. So B is equal to D and D is equal to H, that means B is equal to H. These are known to be alternate exterior angles. Similarly, A is equal to G, angle A is equal to angle G. So we have got 4 pairs of alternate angles, 4 pairs of vertically opposite angles, 4 pairs of corresponding angles, 4 pair of alternate angles. Let's see the next. Now we have linear pair. Linear pair, that means we know that sum of all the angles on a line is 180 degrees. Suppose this is a line and sum of this angle and this angle, this plus this will be 180 degrees. So we call them as linear pair. So here A and B, angle A plus B will be 180 degree. I am not putting up the sign of angle, but you just try to understand. This is angle A plus angle B is 180 degree. Then angle C plus D is 180 degree on the same line. Then B and C on the same line, B plus C will also be 180 degree, and A plus D will also be 180 degree. Right? Similarly, F plus E, E plus H, H plus G, G plus F, all of them will be 180 degree. So we call them as linear pairs. Right? Next is interior opposite angles. Interior opposite angles. Now what's that? See here, angle D plus angle E, they are known as interior opposite angles, right? One of them is this angle D is below this line and angle is above this line. So angle D plus angle E, they are opposite to each other, so their sum will be 180 degree. Angle D plus angle E, sum is 180 degree. Similarly, angle F plus angle C, sum is 180 degree, right? So sum of interior opposite angles is 180 degree. So we got to know about linear pair, interior opposite angle, alternate angles, vertically opposite angle, corresponding angles. So these are the various angles which are formed when we draw two parallel lines and transversal, that is intersecting both of them. Okay, and that's really important. Just revise this part, particularly this part 2 to 3 times, so you must be able to learn them in better manner, right? Suppose I just take one example, and with this I have this line, then I have one more line, suppose parallel to this, then I have this transversal with me. Now suppose I have been given any one of the angle, right? Maybe this angle to be say 50 degree, right? And I have to find out all the other angles which can be formed between among these three lines, right? So that I can do it very easily. Now if this angle is 50 degree, being linear pair, this angle will be 130 degree, right? This is 130 degree. Now this is 50 degree, it will also be 50 degree. Reason, corresponding angles are equal, both of them are on the same side of the parallel lines. Okay, now this is 130, this will 130, vertically opposite angles, or we can say linear pair 50 and 130. Now this is 50, this will also be 50. Reason, vertically opposite angles are equal. Now this, you can see the shape of Z. So this is 50, this is 50. Similarly, this is 130, this is 130. Okay, then this is 50, this is 130. Sum of interior opposite angles is 180 degree. Here also it is 180 degree. Okay, this angle surely be 50. 130 plus 50, 180. It's a linear pair, and this is also a linear pair. So if you know one angle, you can find out all the other angles very easily if you have two parallel lines and one transversal intersecting them. Okay, so that's really important. Now let's see types of triangles. A triangle whose all the sides are unequal is called a scalene triangle. Triangle is a closed figure, precisely it is a closed figure having three sides. Okay, so three sides and triangle, that means three angles. So they have three sides and three angles. So here we can see side AC, side BC and side AB, right? Angle A, angle B, angle C. Right? If all the three sides are unequal, that means all the measures of all the three sides is different from each other, one another, then they are known to be then this sort of triangle is known to be scalene triangle, right? So here ABC, triangle ABC is known to be a scalene triangle when the length of side AB, BC and AC, none of them is equal. A triangle two of whose sides are equal in length is called an isosceles triangle, right? In this triangle ABC, AB is equal to AC, but the third side is not equal to the two sides. So AB is equal to AC, which is not equal to BC, right? So in that case, we know we call it as isosceles triangle, right? When the triangle is isosceles, two sides are equal, and the two sides are equal, then two angles will also be equal. Okay, so if side AB is equal to side AC, then this angle, that is angle B, will be equal to angle C, but both of them will not be equal to angle A. I can take a very simple example. Maybe suppose you have been given angle A, angle B and angle C as 45, 45, 90. Then it is an isosceles triangle because two angles are equal, right? And suppose you have 30, 60, 90. Then this is a scalene triangle because all the three angles are different from one another. That means the sides will also be different, unequal in length. So it is known to be scalene triangle. Okay. And the third is equilateral triangle. Now a triangle all of whose sides are equal is called an equilateral triangle. That means AB is equal to BC is equal to AC. If the three sides are equal, the three angles will also be equal, right? And we know the sum of the three angles of a triangle is 180 degree, right? Angle A plus angle B plus angle C is 180 degree. and since all of the angles will be equal, I assume angle A is equal to x, then angle B will also be x, angle C will also be x. So x plus x plus x, 3x is equal to 180 degree. That means x is equal to 60 degree. That means if it is an equilateral triangle, each angle will be of 60 degree. That's really important. So in an equilateral triangle, the three sides are equal and each angle is of 60 degree. Okay. Then next we have the other types of triangles in when we take case of angles, right? So we have acute angle triangle, then we have obtuse angled, then we have a right angle. So the important thing is, in each case the sum of the angles will be restricted to 180 degree, right? The sum of three angles of a triangle, maybe it is acute, obtuse or right, the sum of the three angles will be 180 degree, right? Now acute angle means what? All the angles are less than 90 degree. Okay, all the angles are angle A, angle B, angle C less than 90 degree. Okay, not even equal to, none of them can even equal to 90 degree if it is an acute angle triangle. Okay, then if it is an obtuse angle triangle, exactly one, not at least one, but exactly one angle will be more than 90, right? So suppose I can say angle A, angle B, angle C, it is maybe 120, it is 30, and it is maybe 30. So this is an obtuse angle triangle. In no triangle more than one angle will be more than 90 degree, right? So it is not at all possible because the sum is restricted to 180 degree. So in an obtuse angle triangle, exactly one angle will be more than 90. In acute angle triangles, all of the angles will be less than 90, and in right angle, exactly one angle will be of 90 degree, right? So suppose I can say 90, 60, 30. So this is a right angle triangle. The remaining two angles will be acute angles. Okay. So acute angle, obtuse angle, right angle. All the angles will be less than 90. One angle will be more than 90. Exactly one angle will be equal to 90. Okay. So the difference among acute, obtuse and right is clear in your mind. Acute angle triangle, obtuse angle triangle, right angle triangle. Now let us discuss some important theorems related to triangles. Here the side of a triangle is produced, the exterior angle so formed is equal to sum of two interior opposite angles. See how it happens. Let's see. I just draw one more diagram over here. This is a triangle, and suppose I just extend one of the side. Okay. Now just see the explanation carefully. This is angle A, angle this is B, and this is C. Okay. Now this I assume to be X. Now angle C plus angle X should be 180 degree. It is linear pair, the angles on a same straight line. So angle C plus angle X will be 180 degree. Okay. Now angle A plus angle B plus angle C is 180 degree. Reason? It's a triangle. Okay, and sum of the three angles of a triangle is 180 degree. Okay, now angle C plus angle X is 180 degree, angle A plus angle B plus angle C is 180 degree. This is 180 degree, this is 180 degree. That means we can equate them. So angle C plus angle X is equal to angle A plus angle B plus angle C. That means angle C and angle C is cancelled. That means angle X is equal to angle A plus angle B. That means this angle is equal to sum of this angle and this angle, right? So if a side of a triangle is produced, the exterior angle so formed is equal to sum of two interior opposite angles. Okay, so that's pretty simple. If you extend this side, then this angle will be equal to angle A plus angle C. Similarly, if you extend this, so this angle will be equal to angle B plus angle C, the interior angles. Okay, be careful about it. So I hope you are getting this concept, and that's really important theorem. We just talked about triangles and lines. Now we talk about the polygons. Polygons, that means n sides, you can say. Okay, if all the sides of a polygon are equal, then it is called a regular polygon. Here we can say a rectangle, not rectangle. Here it is a pentagon, here it is a hexagon, here rectangle, it's a triangle, it's a hexagon. Okay, now see, this all of them are polygon, but may or may not be regular polygon. In case of regular polygon, all the sides should be equal. So this is a rectangle, as opposite sides are equal, that means this length is equal to this length, but this and this length is equal to this length, but all the four lengths are not equal, so it is not a regular polygon, right? But if we talk about square, then it's a regular polygon because all the four sides are equal. Here we can say pentagon. See, when there are four sides, four angles are there, then it is a quadrilateral, right? Quadrilateral. A four-sided figure is known to be quadrilateral. Then there are different types of quadrilateral, depends upon the length of their sides and all that. So that's a different discrimination, that is parallelogram, quadrilateral, then this a rhombus, square, rectangle and all that. Okay, then we have this pentagon. When we have five sides and five angles, a five-sided closed figure, you can say it's a pentagon. A six-sided closed figure, hexagon. Three-sided closed figure, we have already discussed, a triangle, right? Seven-sided figure, heptagon. Eight-sided figure, octagon. Okay, so now we just talk about the sum of interior angles of all these polygons. Let's discuss some important theorems, concepts related to polygons. In a convex polygon of n sides, the sum of interior angles is equal to 2n minus 4 right angles. Okay, now n can be 3 or more over here. If it is a triangle, put the value of n as 3, so you'll be able to get the sum of all the angles of a triangle, right? N is equal to 3, then 2 into 3, 6 minus 4, 2 right angles. So 2 into 90 degree, 180 degree. Okay. Similarly, if n is equal to 4, n is equal to 4, that means it is a quadrilateral. So it is 2n minus 4 into 90. When n is equal to 4, 4 into 2, 8 minus 4, 4 into 90, that is 360 degree. So sum of all the angles of a quadrilateral is 360 degree. Maybe it is a square, maybe it is a parallelogram, a quadrilateral, normal, rhombus, or any other closed four-sided figure. So sum of all the angles will be 360 degree. As of now, we are not commenting on individual angles because it depends. Okay, if it is a regular polygon, then the angles will be same. If it is not a regular polygon, then all the angles will be different from each other. Okay, similarly, if we have n is equal to 5, n is equal to 5, that means it is a pentagon. So if it is a pentagon, the sum of angles will be 2 into 5, 10 minus 4, 6 into 90, 540. Okay, and similarly, if it is n is equal to 6, that means it is a hexagon. Then 6 into 2, 12 minus 4, 8 into 90, 720 degree. Okay, so when it is a triangle, the sum of angle is 180 degree. When it is a quadrilateral, sum of angle is 360 degree. When it is a pentagon, sum of angle is 540 degree. When it is a hexagon, sum of angle is 720 degree, and so on. You can calculate by putting the value of n as 7, 8, something like that, right? Now this is what the sum of angles, sum of all the angles, right? Now if it is a regular polygon, then we can calculate the value of each angle, right? If it is a regular polygon, that means if it is a regular triangle, or we can say if it is an equilateral triangle, then each angle will be 180 by 360 degree, right? Similarly, if it is a regular polygon, a regular quadrilateral, that means all the sides are equal, then each angle will be 360 by 4, 90 degree, right? Then if it is a regular pentagon, then each angle will be 108 degree. If it is a regular hexagon, then each angle will be of 120 degree. Okay, so that's pretty simple. You know the total value of the angles, then you just divide by the number of angles, you'll be getting the value of each angle. Now an important theorem or logic you can say over here. In a convex polygon of n sides, the sum of exterior angles side produced in order is equal to 4 right angles. Okay, now what it wants to say, I just take the example of a pentagon over here, and you can solve it for all other polygons also. Okay, suppose this is angle A, this is angle B, angle C, angle D and angle E. Okay, this is P, Q, R, S, T. Okay, now this is a polygon of 5 sides. Okay, it's a pentagon polygon of 5 sides. Now P plus Q plus R plus S plus T, right? I'm not writing down, not making the sign of angles, but you just understand P plus Q plus R plus S plus T is equal to 540. Sum of angles of a pentagon is 540. We have just done it, right? Now P plus A is 180 degree, being a straight line. So P plus A is 180 degree. Q plus B, it's also 180 degree. R plus C, same reason, linear pair, 180 degree. S plus D, 180 degree. Then T plus C, 180 degree, right? Here A, B, C, D and E, all of them are exterior angles. How do we find the exterior angle? When you produce this side, right? When you produce this side, whatever the angle that is formed between this side and this produced part is known to be exterior angle. So that maybe I'm not able to communicate in my language, but you can see over here that this is angle B is exterior angle, angle C exterior angle, D, E and A, all of them are exterior angles. Okay, now P plus Q plus R plus T is 540 degree, and we have written this various relationships over here. So if you add up all of them, what you'll be getting? P plus Q plus R plus S plus T plus A plus B plus C plus D plus E. Okay, so if you add all of them, you'll be getting 180 into 5, that is 900. Okay, 180 into 5, 900. Now from these, P plus Q plus R plus T is 540. So this is 540. That means A plus B plus C plus D plus E is equal to 900 minus 540. So that is 360. Okay, so that's very important concept, or you can say important theorem. Sum of all the exterior angles of a convex polygon is 360 degree, whether it is a pentagon, it is a hexagon, or maybe it is a quadrilateral. Okay, so be clear about it, just note it down. So friends, I think that's enough in this session. In the next session, I'll be discussing, or I'll be taking more terminologies, concepts and theorems related to triangles, polygons and all of them. Do revise this session, and I'll see you in the next session once again. Bye bye.